This video is going to take you through the 8-4 warm-up and then a review for your test. A reminder that at the end, you're going to submit not only the warm-up, but also the notes for the review. So make sure that you're taking those notes while we go. So in 8-4, there were three theorems that we talked about. One was with the parallel lines inside a triangle, and that is that if the lines are parallel, it cuts the triangle into proportional sides. The second one being parallel lines cut off lines in proportional segments. And the third being if there's an angle that's bisected, it cuts the opposite side into proportional parts. So if we look at this warm-up, there is one of each of these examples. The first one being the triangle with the parallel sides. Because these two are parallel, it cuts these into sides that are proportional. So there's a couple different ways to set it up. You can either do 20 over 10 equals x over 6, or I could do left to right, left to right. So 20 over x equals 10 over 6. I could even go right, left, so you could reverse it. Because the 20 over 10 reduces to 2 to 1, that's going to be the easiest setup. And then we would just cross multiply from here. 2 times 6 would equal 1 times x, or x, and x would equal 12. And again, it wouldn't matter if I had done it the first way or if I had done it this way, I would have gotten the same. Number 2 is your proportional segments cut off by 3 parallel lines. So I can say x over 12, so I went top to bottom, would equal top to bottom here, 18 over 16. Or I could go left to right and left to right. I could say x over 18 equals 12 over 16, or reverse either of those, bottom to top or right to left. So these two are both pretty easy just because you can reduce both of them. Let's say I start with the one on the top. This 2 goes into both of these, so it would be 9 and 8. And I'd get x over 12 equals 9 over 8. Cross multiply from here. 8 times x equals 12 times 9. 8 times x would equal 108. And then divide both sides by 8. And x equals 108 over 8. I can reduce that. You can start with 2 goes into both of these. It would be 54 over 4. And then 2 again, 27 over 2. And I can even take it a step further and say that that would be 13.5. So either one of these would be acceptable as answers, or even 13 and 1/2. That's fine too. Okay, number 3 is that third theorem, which is the angle bisector. It says down here that 1 is congruent to 2. So because these are congruent, there's your angle bisector. It cuts the opposite side into proportional segments. So I can either say 10 over 14, so I'm going left to right here, would equal 17 over y, also left to right. Or I can go left, left, so 17 over 10 equals right, right, y over 14. And you can even reverse each of those. Since you can simplify that top one, I would start there. This would be 5 to 7. So 5 over 7 would equal 17 over y. And then cross multiply. 5 times y would equal 17 times 7. 5y would equal 119. And then I would divide both sides by 5. It doesn't go in evenly, and it can't be reduced, so you can either leave it as 119 over 5, or you can divide. 5 would go into 11 twice. 5 would go into 19 3 times. Add the decimal, and 5 would go into 40 8 times. So this would also be 23.8. Those are questions from your warm-up. Make sure you show all the work. Make sure it's included in the review note. So again, you're going to submit all in one note what follows this. So your Chapter 8 test covers sections 8.1 to 8.4. So not a lot of material. 8.1, 2, and 3 were on your quiz, so good news. And 8.4 was what we added on Friday. So 8.1 was your similar polygons. We start with the definition of similar polygons. So similar polygons have congruent corresponding angles and proportional sides. So if I had two polygons and it asked me to show that they were, or asked if they were similar, then their angles would have to be marked as congruent. So A with J, K with B, D with M, and 3, 4, 1, 2, 3, 4, C with L. And then the sides would have to have the same scale factor. So let's just say this is 2, this would be 4, this would be 3, this would be 6, this would be 5, this would be 10, 4, and 8. So as you match up all those sides, they would have the same ratio. That ratio is called the scale factor. And the scale factor here could either be 2 to 1 or 1 to 2, unless they specify a specific order, like find the scale factor of the small to the large, then it would be 1 to 2. It could also ask you for the corresponding angle pairs, which would be angle A is congruent to angle J, angle B is congruent to angle K, angle D is congruent to angle M, and angle C is congruent to angle L. It could ask you for the ratio of the corresponding sides. So I would match up each side length. AB would go over JK, BC would go over KL, DC would go over ML, and AD would go over JM. And it could also ask you for your statement of similarity or similarity statement, which would be that A, B, C, D, and you have to pay attention to or the letters, would be similar to J, K, L, M. In 8.1, we also added the scale factor is the same as the ratio of any side lengths or segments like your medians and your altitude, and it also equals the ratio of your perimeters. And then when we square the scale factor, we get the ratio of the areas. So I want to stress that in order to get credit for today, you are not taking a picture of the screen. You are rewriting these in your own note. that was 8-1. So obviously we're going to add the next 3 sections, but you need to make sure you have all that written out. If you need to pause so that allows more time for everybody to copy it down, go ahead. If not, we're going to continue. 8-2 and 8-3 we're going to put together. This is your angle, side angle, side, and side, side, side. Similarity, not congruence. So these all tell you that 2 triangles, specifically triangles, are congruent. Angle, angle, they would have 2 angles the same. So here and here, or here and here, they would be similar. Side angle, side would need 2 proportional sides and the included angle. So even something like this, 2 to 4, 3 to 6, and then the vertical angles, that would be side angle, side. Again, side angle, side similarity. And then the last one is side, side, side similarity. And for these, you would need all 3 side lengths. So 2 to 4, 3 to 6, 5 to 10, something like that. And all 3 side lengths would have to be proportional, not necessarily congruent, but proportional, because we're proving these similar, not congruent. So all of that was on your quiz. And then we added 8-4. Which was your proportionality theorems. And the first one was dealing with the parallel sides in a triangle. So triangle proportionality theorem, which said that if the sides of a triangle are parallel, then it cuts the sides of that triangle proportionally. So if this was if those were parallel, and this was x, y, a, b, then x over y would equal a over b, or x over a would equal y over b, or the reverse of those, so we could go right to left. That was like number 1 from your warm-up. The second one was the converse to that, which said if the line divides the sides proportionally, then the line is parallel. So in this case, you would know that they were proportional, like 2 to 4 and 3 to 6. And then you'd be showing that these 2 sides were parallel. The third theorem is the 3 parallel lines theorem, which said if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So if I have 3 parallel lines, and they intersect 2 transversals, then each of these segments are cut proportionally. So if this is my x, y, a, b this time, then x over a would equal y over b, or x over y would equal a over b. And the last theorem is your triangle angle bisector theorem, which says If a ray bisects the angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. A lot of words. But if you just draw out a triangle, or if you see a triangle drawn with an angle bisector, and it would either be marked or it would say it was an angle bisector, then it divides those proportionally. So if this is X, Y, A, B, then we can go top and top. So X over A equals Y over B. Or I could go X over Y equals A over B. The tricky example we had with this in the notes was where you, instead of giving them in each part, it said like 5, let's say 5 and 7, and then it said X, and it would give you this whole side length, let's say 10. So in this case, you can't use X and 10. You can use 5 with X as one of your ratios, but then 7 would have to be matched with whatever segment is here, which is actually 10 minus X. So it would be 7 over 10 minus X. Or you could do 5 over 7 equals X over 10 minus X. Either way, from here, you would cross multiply, distribute the 5. So I'd get 5 times 10, which is 50. 5 times X equals 7X. And then I'd add the 5X. 50 would equal 12X. Divide both sides by 12. And we can reduce this to 25 over 6, or 4 and 1/6. So just be really careful with the ones that give you that whole side length. Make sure you chunk it up into the two parts that are divided where the angle bisector hits that last side. All right, make sure you submit your notes. You can use the remaining time to work on your chapter test assignment, chapter test review assignment. And good luck studying.